Okay, we're in section 6 and we're going to do the examples now. Again, we presented the lecture material. We're moving on to do examples to reinforce what was said during lecture. So let me switch screens to the whiteboard. Just give me 1 second. Okay, I'm going to read it to you. So number 1, it's just reading. It says, without using a calculator, you need to evaluate the arcsine of a half. All right, so I want to remind you the way to think through this. It's not a memorization skill, it's a thinking skill. All right. And I just want to point out the invertible region of the arcsine. Let me push this over a little bit. And I'm going to draw a picture of the invertible region of the arcsine function. So the arcsine function, the invertible region of the sine would look like this over here. All right. And you should have, sort of a good understanding of graphing the sine function. Again, this is a sine function. This is sine of x. And I certainly want to emphasize that we have points over here to concern with. The points we have over here is the last point, the ending point is going to be pi over 2, comma 1. This point over here is 0, 0. And this point over here is going to be minus pi over 2, comma, minus 1. So the range of this is going to be from minus 1 to 1. And the domain of this is going to be from minus pi over 2 to pi over 2. And we're talking about the sine function. Now, we're moving on to the arc function now. So what I'm looking at is, I'll write this down. We're looking at arcsine of 1/2, right? So this is the ratio, and they want to know what the angle is, all right? So I'm going to go over here and point out what the ratio means. The ratio is a half, all right? So the ratio is a half. And I'm going to point out, this is the ratio over here. All right, so the ratio is a half. Question is, what's the angle? Now, I hope you realize the angle's got to be between 0 and pi over 2. Then the big question is, what angle gives you a ratio of 1/2 for sine? Well, that would be 30 degrees. I'll put this down for you. In radian measure, that would be pi over 6. All right. So I want to emphasize again what this is over here. This is a ratio. And these are the angles. All right. Let's go to the next question. And looking at it, certainly when I look at these things, I want to make sure you know what you're doing. And number 2, if I'm looking at this thing, the first thing I notice is arc function. And on the inside of the arc function is a sine function. So let's take a look at one step at a time. All right. I want to evaluate the sine of 4 pi over 5. All right. This over here. So this is going to be the arc sine of some number. All right. So let me just remind you, 4 pi over 5 times 180 degrees over pi. Well, that goes in, pi divided by pi is 1. And let's see. I guess I got to do some arithmetic here, don't I? And what do you get over there? You get what? 5 into 180. I'll write that down for you. Let's see. Three. That's not so bad, right? 15. 3, 0. 6. Well, what's 4 times 36? Well, 4 times 36 is going to be, let's see, 120 and 24, 144, right? Well, that's not helping me, by the way. I'll tell you why. I don't know the sine of 144, all right? So I want to go back and say, maybe I should think about this more carefully. And I really can't do that. I erase this business over here. That didn't help me. I can't do that. So I'm just going to go back and just, sort of like recollect what you need to do. And I'm going to think about it. All right. So I'll put a little picture down of the invertible region. Oops. Of the sine function. And I'll put this over here. Again, it looks like this. Well, I know the domain, know the range of it. And then the question is, 4 pi over 5, right? Well, that has a reference, doesn't it? Right now, before I get there, I want to point out to you that it's not in this numbers over here. These numbers go between minus pi over 2 and pi over 2. So let's just talk about the reference angle for this, the reference. And what would that be? Well, I'm going to put this down. It's going to be pi minus 4 pi over 5, which would be pi over 5. That's not so bad. So at least I know the reference angle is pi over 5. Now I got to start to worry about what quadrant are we in, right? We're in the second quadrant. So the sign, the ratio's got to be positive, right? Now, of course, I'm looking at it. I want to point out what this gives me. This gives me the ratio. Although I don't know what the ratio is, doesn't matter to me. I want to know what the angle is. And what's the angle going to be? It's the reference, which is pi over 5. Okay, let's keep going. Without using a calculus, number 3 now. I'm thinking about it. Again, I want to think about these invertible regions. Now I got the cosine. I'm going to talk about the invertible region cosine. We're doing number 3 now. So I'll put my little picture down. And it looks like this over here. And again, this is cosine of x, not arc. Right? What's the domain of this guy over here? From 0 to pi. And the range of this guy over here, minus 1 to 1, just like we discussed in class. So what are we looking for? We're looking for the ratio. All right, now the ratio, looking for it. Put this over here. This is, 0, 90, 180. I'm looking for the ratio, and that's minus root 3 over 2. That's over here somewhere. Now, I hope you realize the angle has got to be between 90 and 180 degrees. But again, I'm still looking for that reference. All right. And again, I know the angle's between 90 and 180. And what do I know about it? It's a cosine function. And the reference would give me a, let's see, I'm getting cosine root 3 over 2, right? I'm looking for reference, positive triangle. And that would be 30 degrees, right? So the reference is 30 degrees. But again, I know it's between 90 and 180. So what does that mean? It's 150 degrees. So write this over here. Arc cosine minus root 3 over 2 is 150 degrees. You should also write down, certainly what we're talking about here is in radians, we got degrees down. And, 30 degrees in radians would be, well, that would be pi over 6, right? So it's going to be 5 pi over 6. Okay, look at the key. We got this. Again, I want to emphasize over here is this is a ratio. These are the angles that it's returning over here. All right, let's go to number 4. And again, when I do number 4, it says without using a calculator. So again, what I'm going to do is just draw that invertible region for the sine function. And the invertible region sine function looks like this over here. And then the question is, what's the ratio? The ratio is 3/2. Well, I hope you realize the sine function tops out at 1. So 3/2 up here, it doesn't hit it. So I'm going to say that there's no answer to this problem over here. Now, the fact is, we say there's no real answer to this over here. So I want to circle it over there. I couldn't find a place that hits non-real result. Not possible. All right. All right, let's go to the next one, which is number 5. And again, when I do these things, I want to draw the invertible region of the cosine function. That looks like this over here. And I want to find the ratio of minus 1. And where did that occur? That occurred at 180 degrees. And write that down for you. So the arc cosine of minus 1 is 180 degrees, or pi. And that's the angle. Okay, let's keep going. Oh boy, 6 looks really strange to me. It's an arctan function. I'm going to put the invertible region down for the arctangent. Asymptotes in. And it looks like this over here. The question is, where's minus root 3 over 3? It's over here, right? So I know the angle's between minus 90 and 0 degrees. I know it's between those two. All right, so the big question now becomes is, like, how do I get that? Well, I got to get a reference angle. So I'm looking at the root 3 over 3. And I want to get the reference angle. And this looks strangely written to me. It's really 1 over root 3. And do I know the reference for that? The reference for that, let's see, 1 over root 3. That would be 30 degrees, right? So what's the angle? It's between minus 90 and 0 degrees. That would have to be minus 30 degrees. Let me write that down for you. So the arctangent, I'll write this a little bit differently with that minus 1. That means the inverse tangent of minus root 3 over 3 is, well, it's between minus 90 and 0. So that means, and it has a reference of 30, minus 30 degrees or minus pi over 6. Again, I was given a ratio, minus root 3 over 3, and the angle that it returned for the arctangent was minus 30 degrees. Got this right over there. Let's go to number 7. And number 7 says the arctan of 1. All right, well, I got my picture up already. So, 1, the ratio is 1. So, 1 definitely hits it. It hits it between 0 and 90 degrees. And what's the reference for that? Again, the reference for this over here is a 45-degree triangle. What is it between 0 and 90? I'm pretty comfortable. This is a pretty easy one to do. Arctangent of 1, same thing as writing this down over here, inverse tangent of 1. Well, it's between 0 and 90 with a reference of 45. So 45 degrees. And again, you should get used to writing your rating down as well, pi over 4. All right, that's done. The answers are listed over there. Go to problem number 3. And it says, using a calculator, you want to estimate what this is. So I put this over here. Arc sine of 0.987, inverse sine or arc sine 0.987. If your calculator is in degree mode, right? If it's in degree mode, it's going to return on a calculator an approximate number, all right? Now, I want to be honest with you, before you do that though, I guess you probably should know that it's close to some number. So 0.987, if I just drew a picture of this in verb, region, and sine, is going to be close to pi over 2, all right? Or close to 90 degrees, just looking at it. Again, they say use a calculator. You got to use a calculator. If you're struggling with the calculator though, please come by during office hours and I can help you with that. And what is it going to return? I'm hoping if you do it the 4 decimal places, you would get 80.7513 degrees. And if you were in radian mode, it would return 1.4094. Make sure to go back and forth between the two. If you look at my notes, by the way, I put down the SAGE code for doing that problem. All right, you can use SAGE if you like. All right, let's do number 9. Number 9 again says use a calculator. And my claim about using a calculator, again, if you don't use a calculator, it's pretty easy to do that. You're actually going to do this. If you do it in a calculator, before I do it though, I want to point out the invertible region of the cosine function looks like this, right? And minus 0.895 would be down here somewhere. All right, I'm not saying I know what the number is, but it's between 90 and 180. It's certainly closer to 180. All right. I'm sorry, that's not 0.8. I'm sorry, I made a mistake there. Let me back up. It's minus 0.08. I'm sorry. That's a really small number. It's over here somewhere. It's certainly bigger than 90, right? But not much bigger than 90. And that's why I certainly made a mistake in reading the number. But again, if you use your calculator, I want to claim you should be getting these numbers over here. If you're in degree mode, this number over here if you're in radian mode. Likewise, this one over here, your calculator has this on a calculator, you should be getting these numbers over here. All right, you should be. All right, let's take a look at number 11. I know it's difficult. As I do these things over here, I want to point out this looks like a difference formula to me. I'll write this over here, A and B. All right, so it's like cosine of A minus B. A minus B. What do you get? Cosine A, cosine B plus sine A sine B. Well, let me write this down for you. And what do I have? I have arctan. Write this over here. Of 4/3. All right. Now, someone says, could you figure out the angle there? And I'll be honest with you, no, I can't. But what I do know is it's between 0 and 90 degrees. I know that much. What else do I know? I know if it's between 0 and 90 degrees, I have a reference that's acute. I'm going to draw my acute triangle now. And I'll put this over here. That would be 4. That would be 3. Wow, that's easy, 5. So if this is the case, this is the angle theta. I know the sine of theta now. You know what? I can't call that theta. I got to call that what it is. I said it's A, right? All right. That's an angle. Let me just get my eraser out. I'll write this down. Sine of A is 4/5, and the cosine of A is 3/5. All right, let's do the other one, which is the sine, arc sine of 3/5. Now the ratio is positive, so I'm still between 0 and 90. It's still an acute angle. So my triangle down. I called this B, if you remember. And that would be 3, 5, 4. So I know the sine of B is 3/5, and I know the cosine of B is 4/5. So I can write this down now. What's cosine of A? 3/5. What's cosine of B? 4/5 plus the sine of A, 4/5, and the sine of B, which is 3/5. Well, if you do that arithmetic, you get 25 in the bottom. You get 12 plus 12, which is 24. 24 25ths. I also put down the SAGE code for that for students who are interested in doing the SAGE code. All right, let's go to number 12. And number 12 is use a calculator, evaluate arc sine of -3/4. There's a point to this one over here because a lot of people use their calculators and they say, oh, my calculator can't do that. And it's true. If you type into your calculator the arc cosine of -3/4, your calculator is just going to respond back to you with what you just typed in. It's going to say the arc cosine of -3/4. If you want to approximate it, though, you're going to have to put a decimal somewhere. And I'm going to say, 4.0. This is going to force your calculator to return a number. Right? When I say a number, a decimal number, the numbers that you return is this one over here if you're in degree mode, and this one over here in degree mode. Make sure you know the difference. And if you don't know the difference, come by during office hours and we can help you. All right, let me look at number 13. Number 13 says use the properties of the inverse functions to find the exact value of this expression over here. So let me write this one down. And it's going to be arc cosine. And I got 11 pi over 2. I'm going to point the wheels on the bus go round and round. Let's see, 11 pi over 2, right? So it's going to be 1, 2, 3, 4, 8. Wow, that's a lot, isn't it? 9, 10, 11. I'm over here. All right. So then the question becomes is, what's the cosine of that number? Right? So the cosine of that number is minus, let's see, not minus, is it? What am I saying? Let me go backwards. I'm talking about the cosine now, right? So I'm on, minus 270. Let me talk about that. Not minus 270, 270. Let's see. Put this over here. Ooh, we're at 0. I'll put this over here. All right, 0. That's the ratio. Okay. Let's go backwards and talk about the invertible region of the cosine now. Looks like this. Where does that occur? At 90 degrees, or pi over 2. All right, let's go to number 14. And this has to do with a picture. All right. So it says right now the expression is equivalent to the expression, hint, right triangles. And I'll put this down. I want to point out, though, that this over here represents some angle. I'm going to call it theta. And they said use a right triangle to do that. I'll put this over here, theta. All I know about this is if the arc sine, x minus 1, equals theta, then I know the sine, I know the sine of theta is equal to x minus 1 over 1. That's the ratio. Let me write this down. X minus 1, 1. Let me put the other side down. As I do this, I want to point out, there could be some problems over here, but let me point out what I'm looking at. I'm on Pythagorean theorem, right? So it's going to be 1 squared. That's the radius squared equals x minus 1 squared plus, I'll just put a question over here. Let me see if I can do this. 1. This would be x squared, right? Minus 2x plus 1 equals the question mark. I'm sorry, I didn't mean to say equal. I'm really daydreaming here. Plus the question mark squared. Let's see if I can do that. Take away 1 from both sides, add 2x to both sides, subtract x squared from both sides. I got trouble now. I'll tell you why. The question could be plus or minus the square root of 2x minus x squared. All right, think about it now. When I'm going to think about the arc sine function, if I thought about the angle here, the angle would have to be between, minus 90 and 90 degrees, right? I hope you remember that. Now, what do I know about the secant in that range over there? The secant in that range over there has got to be positive. So I know this question now. It's got to be a positive number. Get my eraser out, and I'll put that down for you. Whoops. I get my eraser, don't I? And this is going to be the square root, positive, by the way, 2x minus x squared. So what's the secant of that? Well, the cosine of that would be, let's see, the side, which is root 2x minus x squared over 1. And it's going to be reciprocal now. So what do you get over here? 1 over the square root of 2x minus x squared. Okay, social stage go over there. That covers that section out. And it's a short section. You should be familiar with how to use your calculator and the meaning of the arc functions for sine, cosine, and tangent. Thank you.